Hi, I'm Larry Puckett, the DCC guy. Well, today I've got a number of things to cover with you. First, we're going to take a look back at the Barrina shop lights that I talked about in last week's video because there were a number of questions that came up in the comments about the safety of these electrical fixtures. So I found out a lot about that, and I hopefully can answer all of your questions. I know I've answered all the ones I had. After that, we're going to take a look at 5 electronic products that I want to show you because I think you'll find these to be very useful on your model railroad, just like I have. So let's go ahead and get started. Hit that little red subscribe button, and when the little bell comes up, click on it and click all. Let's go ahead and get started with these Barrina shop lights because I've installed all of mine here on the model railroad, and let me show you that. And I'm only going to leave them on for a minute because they're going to blow the lighting out. But you can see they do provide a lot of light here. This is the entire area of Ty River, and I've got Amherst covered as well. All 6 of the ones that I bought, I have installed, got them all powered up and operating. So they're providing a lot of light down here. Let's go ahead and talk about the safety issues that came up in the comments. Okay, I turned off these lights because they were blowing out the lighting on my camera here. So let's go ahead and discuss these. What I found out from my contacts with Barrina is that these units here are designed as a Class 2 electrical product. So what does that mean? Well, that's going to be something like a table lamp or a lot of other appliances and devices in your house. They're double insulated, and you'll see that on a lot of products, advertisements that they are double insulated. Well, these are as well. What they do is all of the electrical components that are electrified are enclosed within a polycarbonate shell. They've got a polycarbonate tube that those are included in. Also, this piece here, this piece of polycarbonate, it is continuous. So everything that's in here is also insulated from this metal extrusion that forms the base of the light fixture. As a result, everything in here is double insulated. It is not going to come into contact with the aluminum. And even if you get a short circuit internally in the electrical components, they're going to be protected from coming into contact and electrifying this aluminum extrusion here that forms the base of the light. And right here I have a photograph that Barrina sent me showing how this works. You can see down on the bottom the red and the black wire that are coming out of this polycarbonate enclosure where all of the LED driver is located, and then going into the tube that encloses the LEDs. So that is insulated. The LED strip is insulated inside of the polycarbonate tube, and then there's a polycarbonate tube below it where the LED driver and other high voltage components are located. So everything is basically protected from coming into contact with that aluminum extrusion that forms the base of these fixtures. So you're not going to get shocked even if it does short out internally for some reason. And I'll read to you what they said because they sent my question to one of their engineers, and here's what they sent back. First of all, our LED lights are classified as Class 2 products complying with UL 153 and CSA 22.2 standards. And those are the US and the Canadian testing organizations, okay? And so that allows for that 2-pin design for the 2 plugs on the power cord. So they say the lamp bead board or the circuit board of the LED is made of fiberglass board with excellent insulation performance. Additionally, the lamp bead board or circuit board driver and solder units are fully covered by a PC cover, polycarbonate cover, isolated from the metal shell, providing reinforced insulation. The product meets the withstand voltage standard of 1000 plus 2 U's, and I have no idea what that means. Testing requirements, ensuring that there will be no electrical leakage through the metal shell. Then they also say our wiring features a double installation design, meeting the requirements for a Class 2 product. Furthermore, our plugs, wiring, and PC tubes are all made of flame retardant materials. The reason we use a 3-pin connector is to improve the stability of the connection and ensure compatibility with accessories available in the market. So that's their response to this question about the safety of the products, why there is no need for a ground to these, as you would see on some other grounded shop lights, that kind of thing. Now, one other thing that I forgot to show you that is included with the Barrina lights is this little device right here. You can see it's a little triangular shaped device, and what it does, it plugs in right here into the end of this lighting fixture, like that, and it covers these electrical connections that you see inside of that socket and protects them from, and protects you, the user, from getting shocked if you happen to stick a screwdriver in there for whatever purpose you might stick a screwdriver in there. Or you might be able to get your finger in there, I don't know. But at any rate, as long as you use these to terminate a string of these, you'll be protected without any problems. So don't lose those, and that's what they're for. Now, I was satisfied enough with Barrina's response to my questions on the safety of these that I went ahead and I've ordered and already received another set of 6 of these to go in another section of the model railroad that needs lighting. So I was happy enough with their answers to go ahead and commit to using these. And I'm probably going to be ordering another set after that to be used on another area once I get to it. So as far as I'm concerned, they're reasonably safe, no more dangerous than a table lamp that you probably have in your living room right now. Okay, let's move on to the 5 electronic products that I have to show you. Now, one of the questions that I had, or one of the comments that I had at some point during the presentation last week, concerned the amperage of these devices, because I wasn't sure what the amperage was. And at some point, I heard from Barrina that 12 of these inline pulls about 2 amps. But I wasn't sure about that. I was, I wanted to be convinced. And one of the viewers here sent me a comment that there was a device that I should get. It's called a kilowatt. It will allow you to measure things like the voltage of your electrical circuits in your house, and that can be very important. The reason for that, I'll tell you. Several years ago, I was having problems with my backup batteries for my computer. They kept tripping. So I ordered a replacement from Amazon. It came in, plugged it in, did the same thing. So I contacted Amazon and told them I had a defective one. They sent me another one, and it did the same thing. So I was talking over the fence with my next door neighbor the next day, and I asked him if he was having any experiences like that, and he said he was. So immediately a light bulb came on in both our heads. We ran inside, got out our meters, and checked the voltage of our circuits in the house. Well, we were actually getting 140 volts instead of the 120 we should be getting. And we had the power company out here within a few minutes, and then after about 15 more minutes, they had a truck out there and they were replacing the transformer on the pole that served both of our houses. And now the power still is back down around 120 volts where it should be. So it's nice to have a way to test that periodically, and that's what this kilowatt device will do. And that's the generic term for it, kilowatt, and you can look that up on Amazon and you'll get all kinds of these little devices like this that will actually measure it for you. So I got online, ordered one, got it, and I'm going to show you how they work and how I'm using them here on the Piedmont Southern, because they are a nifty little device that should allow you, or allow me anyway, to measure the total amperage of a string of these, or the total amperage of the entire model railroad here, because I do have it all interconnected through one socket that goes into one circuit here in the house. So let's go over to Amherst and also under Monroe Yard, and I will show you how you can use this or a similar device to measure your line voltage and the amperage of any device that you plug into it. And the way these work is they have a 3-prong plug here on the back. You plug them into the wall, and then you plug in whatever device you want to test the amperage of right here. and it will give you that readout. And I'll show you that in just a second. Very simple, easy to use. You just plug it in and it works. And it has a number of 6 different modes on here. So there's one for voltage and frequency. There's one for amperage. There's one for kilowatts, kilowatt hours. You can input what you pay for power in your area, and it will calculate the kilowatt hour cost for the device that you're looking at. So a lot of different things you can do. Really, the only 2 things I was interested in was line voltage and amperage. Okay, so let's take a look down here in the underworld, and I'll show you how I'm using the kilowatt down here. It's showing right now 2.299 amps, so 2.3 amps. So everything on the model railroad right now is running at 2.29 or 2.3 amps. So that's not very much, but you got to remember that all of the locomotives are just sitting there idling. There's nothing running on the model railroad. So once I start moving a bunch of locomotives around and running trains, that value is going to creep up. Let me show you what else you can see here. Okay, I can also change this button here, and we'll, okay, now it's lighting up, good. It only lights up when you're actually using it. So let's move around here. So it's showing different things here, but let's get to the first one. Right now, our household electrical line power is running at 120.1 volts and 60 hertz. So that gives you an idea of that. Move on, and as I said earlier, we're at 2.31 amps. So that's one quick way to check, or using this device to check how much your model railroad is using. Now in this case, you can see I have one line right here that goes to power everything on the model railroad. So I'm able to plug that in, and that includes everything, my Digitrex command station booster, all of the power supplies that run my KD electronic electromagnets for uncoupling, all the other things in here that draw power. So I calculated on paper that I could be drawing up to a maximum of about 10 amps when I'm running everything at full blast. But in general, it's going to be much, much lower, which makes me feel a lot better. I'm not overtaxing my circuit. This is a 15 amp circuit. Okay, let me crawl out of here and we'll take a look at another use. Okay, here you can see the area of Amherst that I showed you the other day. I've got some the lights on here, so these are the last 3 of the fixtures. There's one on my left, one right here in front of me, and then another one back in here. Let me back up a bit. And right here you can see I have the kilowatt plugged in here. You can see we're still we're at 121 volts on this one, 60 hertz. And let me kick up. Okay, the amperage right now with 6 of these Barrina fixtures operating is 0.981. So you're talking about just a hair under 1 amp. Very easy, quick and easy way to discover how much amperage these units are actually drawing. Okay, next I want to zoom in down here on the benchtop to share with you a few things that I've got laid out here. So let's take a look at that. Now previously I showed you these Wago connectors, and I used them when I was building the Helix to do some of my wiring. And at that time I was using these 3-position connectors. Now what I've got here are some of the others that they make. Now this one has 5 different positions, and just as a reminder, you flip this open, insert a wire in here and close it, and then you can insert wires in each one of these positions. So you can make multiple connections to a power source. Here we've got 5 different ones in a line, and you can use it for 3. They've got they have a 2-position connector like this. Okay, and these are all a Wago 221 fixture. The one that I just found out about and have seen a lot lately on YouTube that I wanted to test for myself are these what are called inline connectors. And they're just like the others, except that they are inline. So they are great for doing a splice. Let's say that you have two wires that you want to connect together. You would just open these little guys here, the little levers. Put your first wire in here and close it. Put your next wire in here and close it. And you have a good firm connection. And these are useful for not only the model railroad, you can use these in your household wiring if you're doing something there. So I assume you know what you're doing if you're working with AC. But these are rated for both DC and AC applications. I can see here they're rated at 20 amps at 300 volts. So you've got quite a lot that you can do. Looks like they can be used at anything from AWG 18 to 12. So again, a wide range of uses for these. For a lot of our model railroading needs, they're going to take care of it. And these do have a UL stamp on them, so no issues there. I picked up this assortment off of Amazon. So all you have to do is go on Amazon and look up Wago connectors, and there will just be tons of these available in individual types or in assortments like this if you just want to pick up a few in order to test out. Okay, so let's move on and take a look at something else. Now, in a couple of videos ago, I showed you these Light Effects 16 products from Logic Rail Technologies. And I'll put a link to that video above me here so you can go back and take a look. Let me turn this on. I've got this powered with my NCE power cab right now, but you can also use DC to power these. And once you've programmed these using your DCC setup, you can then power these entirely off of DC power without it having to be connected to your model railroad. So that's an option for you to take a look at. Now I've got two new products that they've just released, and I wanted to update you on one other one. Now when I talked about this board, I said that they were developing a high current version of this board, and that is available now, and it's available on their website. I'll put a link to their website for all their different components in the description, so you can take a look there. And you can just go to the Logic Rail Technologies website by doing a search for it. But at any rate, the new one, the high current version, can put out 250 milliamps per outlet here, and there are 16 outlets, for a total of 1.8 amps for the entire board. So there are some limitations on that anyway. Also, if you're using the high current board, you have to use a dropping resistor on your LEDs. I'll remind you that with the regular board, you don't need any resistors. You can drive them directly using the LED driver. Now, I think you can see here, let me lift it up, I've got this set up. I've got a little green LED in one of the outlets here, and you can see it is pulsing right there. You can see I have this pole light that is a Woodland Scenics Just Plug lamp here, all lit up. And I still have this set up so that I can turn it on and off, some of them. This is the first one. So I can just hit this push button and turn it off, and then I can turn it back on again. Now, what this product right here is their output adapter. And what this allows you to do is install this adapter in its place, and it has a series of screw terminals here. So you can wire up your LEDs directly to it and or wire them in. This is that Just Plug light. I've got it wired in directly here. There is a single positive wire connection here, and then 8 different connections here for the negative. And that allows you to control each of these outlets independently. And then there's another 8 over here on this side. So that gives you a screw terminal adapter that you can use. Makes it a lot easier than having to deal with wiring up individual LEDs and the like using these Just Plug type connectors. You can just wire it directly through these screw terminals. They also have a different version of this adapter that has solder connections on it. So it has the solder tabs for the voltage plus and the individual negative connectors there. So that makes it a lot easier to use than having to use these various Just Plug type 2-pin connectors. Okay, another item that they sent me that just came out is this relay board. And I mentioned that they were developing that in my last video. And so this one just plugs right into one of the output sockets here on the board. And then it has a relay right here that's controlled using the on-off or using your handheld throttle to control the accessory. But it allows you to turn this relay on and off and control a much higher voltage amperage device running here. So that way you'll be able to control a lot of other things, animation, much higher voltage and amperage draw than you would normally using one of these. Now the relay in this is rated at 3 amps and 125 volts. So you can power anything up to 3 amps draw and anything up to 125 volts. And it has a 3-position screw terminal here where you can connect your normally open, your common, and your normally closed connections here. So you can have it on, off, and then control whether or not you're turning the device on or off. So this would be great for a lot of different types of animation on your model railroad that draw more than the normal current that is put out by this board. And again, I've included in the description the link or the URL for the Light Effects 16 board. Okay, now another thing that I wanted to share with you is a use for the alpha meter that I hadn't previously covered. And I did show you how to use these alpha meters. I've got one installed here, down here on the model railroad power supply. And you can see that right now my main bus is, my DCC power bus is 13.25 volts at about 2.41 amps. And that's because I've got about 60 locomotives here on the model railroad that are drawing a minimal amount of current. Well, over here, I have another alpha meter, and this one, it's got a little green light here. The other one had a little blue light. And that blue light indicated that it was measuring DCC power. This one indicates it's measuring DC power. And what I've done is I've run the wire from my DC power supply, which is a 12-volt 6 amp power supply, into the alpha meter and then out to my DC power bus. And right now, as you can see, it's coming in at about 11.9 volts, and right now the load on it is 1.29 amps. So as I add more devices or turn more devices on here on the model railroad, I've got several things that are not plugged in right now, but once those are plugged in and everything is turned on, I'll still be able to keep track of how many amps I am using so I don't overload my power supply, because that's always a concern. I mean, you know how it is. You get on your model railroad and you start plugging in all of these little power supplies that are used for various devices on the layout, and the next thing you know, you're pulling maybe 5 amps, but you don't know. So this is one way to do it. So it's a novel use of the alpha meter to be used to monitor the voltage and amperage of your DC power bus. And I can't tell you enough how useful having a DC power bus is to operate a lot of devices here on the model railroad. Now, I even had one string of LED tape lights underneath of one part of the layout that operates off of the DC power bus. Also, my signals operate off the DC power bus. So there are a number of other things that I do have using the DC power bus. So if you ever need to be able to test that out or want to monitor it on a regular basis, then you can just set one of these up. Eventually, I'm going to be installing this into the fascia here on the Piedmont Southern, so I'll be able to keep track of that all the time and know just how many amps I am pulling through my DC power supply. Well, that's a wrap for today's video. Hopefully you'll find some of these electronic gadgets useful on your model railroad, and you'll be able to get your Barrina shop lights all lit up and illuminating those hidden parts of your layout that you haven't really been able to see what's going on because it's so dark in there. And I know I've got several of those here on the Piedmont Southern myself, and I've got a couple that I still need to install some more lights on. So I'm going to be working on that in the next few weeks. So whatever you're working on, be very safe with your wiring. If you're not experienced in using AC power, then I suggest that you get the help of someone who is, even if it's bringing in an electrician to help you do some of that work. It's probably a lot safer to do that than to try to take it on yourself if you have never done it before. Other than that, have a great week, have a great weekend, and I'll see you here in a couple of weeks with another video from the DCC Guy. Bye now.